completed in types of number system, that is natural numbers, whole numbers and integers. Today we are going to take the rational numbers. Already you have studied in your 8th standard, rational numbers. What are the rational numbers? So first I am going to write down the definition just to observe. Numbers which are in the form of P by Q. They should be in the form of P by Q, where P and Q should belong to what? Z. That is integers. First condition. Second condition, Q should not be equal to 0. And third condition, PQ should be in its simple form. Such numbers are called as rational numbers. Means they are nothing but they are the fractions. So for example, if I take 2 by 5, this is a fraction, can I call this as a rational number? Means you have to check whether it obeys the 3 conditions or not. What is the first condition? P and Q should belong to Z. Z means what? P can be positive, P can be negative. Q can be positive, Q can be negative. So let us see. P is also positive, Q is also positive, they belong to Z. First condition is over. Q should not be equal to 0. Yes, denominator is not equal to 0. So second condition is also fulfilled. Third condition, P and Q should be in its simple form. You cannot reduce 2 by 5, it will remain as 2 by 5. Then this, what you call it as type of number, is called as rational number. But if I write it as 4 by 10, let us see first condition. Yes, P is an integer, Q is an integer. Second condition, Q is not equal to 0. But see the third condition. Is it in simple form? No, I can cancel it. 2 2s are 4, 2 5s are 10. 2 by 5 is the rational number, but 4 by 10 is not a rational number. So came to know. So these are the rational numbers. As we saw that the natural numbers, the whole numbers and integers are denoted by a particular letter. Even rational number is denoted by a letter. So it is denoted by letter Q. So the capital Q represents what? The rational number. Now let us see the properties of rational numbers. What are the properties? There are 3 properties in rational number. First property is closure property. Second property is commutative property. And third property is, what is the third property? Associative property. So let us see the first property. What is the first property? Closure property. But for all these 3 properties, we have to check the 4 fundamental operations. Closure property for addition, for subtraction, for multiplication and for addition. Commutative property for addition, subtraction, multiplication and division. Associative property for addition, subtraction, multiplication and division. Now let us start with the first property, that is the closure property, and the first fundamental operation for addition. Closure property for addition. What is the general rule says? For all AB belongs to Q, then A plus B is equal to C should belong to Q. Now let us take the examples. So first example, A is equal to 2 by 5, B is equal to 5 by 7. So A value is 2 by 5, B value is 5 by 7. What I have to prove? A plus B should be equal to C, which should belong to Q. What is A value? 2 by 5. What is B value? 5 by 7. In addition of fractions, rule says that if denominator are same, you add the numerator and keep the same denominator. But denominator is not same, so we have to take the LCM. What is the LCM? Both are the prime numbers. When the denominators both are prime numbers, just multiply, that will become your LCM. 5 into 7, so you will get 5 into 7 is equal to 35. This is your LCM. Now what we have to do? Take the first rational number. Which is the first rational number? 2 by 5. Multiply with LCM. 5 ones are, 5 sevens are. How much is 7 twos are? 7 twos are 14. So the LCM will come as a common denominator. For the first rational number, you got it as 14. So write it down 14. What sign is there? Plus. Plus. What is second rational number? Take 5 by 7 into 35. 7 ones are, 7 fives are. 5 fives are how much? 25. So plus 25. Now what we have to do? We have to add 14 and 25. So 14 plus 25. 4 plus 5 is 9. 2 plus 1 is 3. So I got it as 39 by 35 belongs to Q. Means you have to check the three properties. P and Q are belong to Z. Both are integers. Q is not equal to 0. Yes, Q is not equal to 0. Are there in its simple form? Yes. 39 and 35 cannot be reduced. So it is in the simple form. So first example is true for the closure property for addition. Let us take the second example. A is equal to 5 by 7. B is equal to minus 10 by 13. So what I have done? I have taken one negative number. So what I have to show? A plus B is equal to C belongs to Q. So what is A value? 5 by 7 plus. Minus is there, I will keep it in a bracket because plus and minus sign cannot be written together. Here also what happens? The denominators are different. Both are prime numbers, so multiply. So what it will be? 13 into 7. So what it will become? 91. So what is your LCM? It will become the denominator. It is 91. Now let us take the first, what you call it as the rational number. What is first rational number? 5 by 7 into 91. 7 13s are. 13 into 5. 13 into 5 is how much? 65. Then what sign is there? Plus. Next is rational number is minus 10 by 13 into 91. 13 ones are, 13 sevens are. Minus 10 into 7 is minus 70. So what you got it as is equal to 65. Plus into minus is minus 70 by 91. So take the bigger number 70. Subtract the smaller number 65. So you got it as 5. See the bigger number. What sign is there? Minus. So you will get it as minus 5 by 91. Now see. Both are integers. Yes, both are integers. Is denominator 0? No. Both are in simple form. Yes, both are in simple form. So it belongs to Q. So from this you can say that the closure property for addition is true for rational numbers. So came to know. Now we'll go to the next closure property for the next, what we call it as fundamental operation, and that fundamental operation is subtraction. So closure property for subtraction. So what is the closure property for subtraction? The first statement will remain as it is. Only what happens over here, this statement changes. A minus B is equal to C belongs to Q. So let us take the first example in this and calculate whether we are able to prove it that subtraction is a closure property for rational numbers. So first example, A is equal to 5 by 17, B is equal to minus 1 by 2. So what I have to prove? A minus B. So A minus B should be equal to C, which should belong to Q. What is A value? 5 by 17 minus, another minus is there, I'll keep it in the bracket, minus 1 by 2. Again you can see here denominators are different. So one is a prime number, another is a what you call it as a whole number. So you have to multiply this 17 into 2. 17 2s are 34. So what is your LCM? LCM is 34. That will become your denominator. Now take first rational number 5 by 17 into 34. 17 ones are 17 twos are 5 2s are 10. So I got it as 10. What sign is there? Minus. Then keep it in the bracket because second sign is also minus. Take the second, what you call it as a rational number. Minus 1 by 2 into what? 34. 2 ones are 2 17s are. Minus 1 into 17 is minus 17. Now next step, 10 will remain as it is. Minus into minus is plus. Plus 17 divided by 34. So what you will get? 10 plus 17 is 27 divided by 34. Are P and Q belong to integers? Yes. Q is not equal to 0? Yes. Can they be simplified? No. So this belongs to what you call it as Q. So first example we saw. Now let us see the second example and try to prove that whether the closure property for subtraction is true for rational number or not. So let us take the second example. A is equal to 1 by 4. B is equal to 3 by 11. So what we will do? We have to see A minus B. So A minus B is equal to C belongs to Q. A value is 1 by 4 minus B value is 3 by 11. Here also you can see one is a prime number and another is what? A complex number. These two you have to multiply. What you will get it as 44. So what is your LCM? LCM is your 44. Now take the first rational number. 1 by 4 into 44. 4 11s are. 1 into 11 is 11. Then what sign is there? Minus. Next rational number. 3 by 11 into 44. 11 ones are. 11 fours are. 3 into 4 is how much? 12. So what you got it as? 11 minus 12 by 44. So one is a positive integer, one is a negative integer. Take the bigger number. 12, subtract 11. 12 minus 11 is 1. See which is the bigger number? 12. What sign is there? So minus. Minus 1 by 44. P and Q are integers? Yes. Q is not equal to 0? Yes. P and Q are in simple form? Yes. So they belong to what you call it as Q. So what does this shows that? This shows that closure property for subtraction for rational number is also true. So we saw closure property for addition and closure property for subtraction is true. Now let us go to the third fundamental operation, that is closure property for multiplication. So what is the closure property for multiplication? Everything is same, but here the sign changes. It will become A into B is equal to C. Now let us take the example. First example to show that whether A into B will become C or not. So both should be a rational number. So let us take A is equal to 5 by 13. B is equal to 11 by 7. So what I have to prove? A into B is equal to C. So A into B is equal to C belongs to Q. So A is what? 5 by 13 into B is what? 11 by 7. Here I want to tell you a very important thing. Now what sign is there? Multiplication. So what important thing you have to keep in mind when two rational numbers are multiplied or when two fractions are multiplied, you will not take the LCM. What you have to do? Numerator should be multiplied with numerator and denominator should be multiplied with denominator. Which is what I have to do? 5 into 11 divided by 13 into 7. So don't make mistake by taking LCM. Multiplication does not have LCM for rational numbers or for fractions. So what we have to do? 5 into 11 is how much? 55. 13 into 7 is how much? 91. So you got it as 55 by 91. Is 55 and 91, that is P and Q are in that is integers? Yes. Q is not equal to 0? Yes. They cannot be simplified, means they belong to Q. Now let us take the second example for this to show whether multiplication is a true for closure property for what? For rational numbers. So A is equal to minus 7 by 13, B is equal to minus 1 by 11. So both I have taken minus sign. So what I have to prove? A into B is equal to C belongs to Q. What is A value? Minus 7 by 13 into B value is negative, I keep it in the bracket, minus 1 by 11. As I told you, what it is? Two rational numbers, when you multiply, you won't take the LCM. Multiply numerator with numerator. Minus 7 into bracket minus 1 divided by 13 into 11. So let us see what happens. Minus into minus is plus. Then 7 into 1 is 7. So you got it as in the numerator 7. Let us see in the denominator. 13 into 11. 11 3s are 33. 3 and carry 3. 11 1s are 11 plus 13 is 14. So you got it as 7 by 143. Okay. So what you got it as? Plus 7 by 143. Both are integers P and Q. Yes. Q is not equal to 0? Yes. Can P and Q be are in simple form? Yes, they are in simple form. That means they belong to Q. So what does the first and second example proves? That the closure property for multiplication is true. So what we saw? Closure property for addition is true, closure property for multiplication is true, and closure property for subtraction is true. Now we will see the last fundamental operation for closure property, that is closure property for division. So here everything remains same, only the this changes, that is A by B is equal to C belongs to Q. So now let us take the example for the division. So we have to take first example. A is equal to 3 by 4. B is equal to 7 by 13. Let me take it as minus 7 by 13. What I have to do now? A by B. A by B is equal to C belongs to Q. What is A value? 3 by 4 whole divided by minus 7 by 13. Here also one important rule I will explain you. When two fractions are divided, put the first fraction as it is. Division shall be converted into multiplication. When division is converted into multiplication, whatever in the denominator the fraction is there, it will become reciprocal. Reciprocal means what? 13 will go up, minus 7 will come down. So what you will get? 13 divided by minus 7. Same I told you when multiplication we were doing, we have to multiply 3 into 13 divided by 4 into minus 7. 13 3s are 39 divided by minus into plus is minus, 7 4s are 28. Both are integers, yes, that is yes. Denominator is 0, no. Both are in simple form, yes. So this belongs to Q. Now let us take the second example for the that is the closure property for division. What is the second example? Where shall we take? Let us see. A is equal to 1 by 4. B is equal to 5 by 9. So what you have to do? You have to do A by B is equal to C. So A by B is equal to C should belong to Q. What is A by B? 1 by 4 whole divided by 5 by 9 is equal to, I told you, keep the first rational number as it is, convert the division into multiplication. So the second rational number will come reciprocal, that is 9 by 5. Again the rule of multiplication, numerator into numerator divided by denominator into denominator. 1 9s are 9, 4 5s are 20. Both are, so what you got it as 9 by 20. Both are integers, yes. Both the denominator is not 0, yes. Both are in simple form, yes, means it belongs to Q. That means from these two examples what we can say that closure property for division is true. So what did we prove? Closure property for addition is true, closure property for multiplication is true, closure property for subtraction is true, and closure property for division is true. Let us see the second property in rational number, that is commutative property. Like closure property, this property also should be checked for the 4 fundamental operations. That is, the first fundamental operation is addition. So let us check it for addition. Now we know that the general form is same. A comma B belongs to Q, then sum of A plus B should be equal to sum of B plus A, which should belong to Q. So A plus B should be equal to B plus C. So let us take the first example. A is equal to 3 by 7. B is equal to 2 by 5. So what I have to prove? A plus B is equal to B plus C means left hand side will become equal to right hand side. And if all these three conditions are there in the answer, means it is belongs to, that is, it is commutative property for addition will be true. So let us take the value of A. What is the value of A? 3 by 7 plus 2 by 5 is equal to, what is B plus A means? 2 by 5 plus 3 by 7. So now pay attention here. Here is 7 and 5 and here also 5 and 7. Both are prime numbers. So the LCM will be same for both of them. 7 into 5 is 35. 5 into 7 is also 35. So I will keep for A plus B also the denominator is 35. And for B plus A also the denominator is 35. Now first I will take the left hand side. What is the first fraction? That is the first fraction or the first rational number, 3 by 7. So 3 by 7 into 35. 7 ones are, 7 fives are, 3 fives are 15. So I got it as 15. What sign is there? Plus. Next rational number is what? 2 by 5 into 35. 5 ones are, 5 sevens are. 2 into 7 is how much? 14. Now see over here. Okay, what is given? 2 by 5. 2 by 5 already I did. 2 into 7 means 14. This reverse I have to write down the result on the right hand side. So 2 by 5 is 14 plus 3 by 7 is 15. So I got it as 15 plus 14 divided by 35 is equal to 14 plus 15 divided by 35. So 15 plus 14 is how much? 29 by 35 is equal to 14 plus 15 also same, 29 by 35. Both are integers, yes. The denominators are not 0, yes. Both are in simple form, yes. Means it belongs to Q. Now let us take the second example. Second example, A is equal to 3 by 4, B is equal to 1 by 2. So what shall I do? Again the same thing. What I have to do? A plus B I should prove it is equal to B plus A. So A plus B is equal to B plus A should belong to Q. What is A value? 3 by 4 plus. What is B value? 1 by 2 is equal to same reverse. 1 by 2 plus 3 by 4. 2 and 4. In 4, 2 table is there, means 4 is the highest number. So when such numbers come, then you have to take the highest number as the LCM. So your LCM is equal to 4. So what you are going to do? Take the first rational number. 3 by 4 into 4. 4 and 4 cancels. 3 ones are 3. So the left hand side also the same LCM will become the denominator. Right hand side also the same LCM will become the denominator. 3 ones are 3. Then plus sign. Next what is given? 1 by 2 into 4. 2 ones are 2 twos are 1 twos are 2. So 3 plus 2. Here what will come? The reverse. Means 2 will come first. 3 will come afterwards. So 2 plus 3. Add it. 3 plus 2 is how much? 5. 5 by 4. 2 plus 3 is also how much? 5. 5 by 4. Both are integers? Yes. Denominator are 0? No. Both are in simple form? Yes. Both belongs to Q. So what can you say from this? That the commutative property for addition is true for rational number. Let us see now commutative property. Commutative property for subtraction. For all a comma b belongs to Q, then a minus b should be equal to b minus a, which should belong to Q. So we have to show left hand side should be equal to right hand side. Let us take the first example. A is equal to 1 by 2, b is equal to 1 by 4. So what we have to prove? A minus b is equal to b minus a. So what is a value? A value is 1 by 2 minus 1 by 4 is equal to 1 by 4 minus 1 by 2. Already I told you 2 and 4 comes. 2 is a prime number. 4 in 2 table 4 is there. So your LCM will be equal to 4. First, what you have to do? The LCM you have got as 4. So on the left hand side also the LCM will become the denominator, and on right hand side also the LCM will become the denominator. So 4 is a denominator over here. Here also 4 is a denominator. Now take the first rational number. 1 by 2 into 4. 2 ones are 2 twos are. 1 into 2 is 2. You got it as 2. Then what sign is there? Minus. Take the second rational number. 1 by 4 into 4. 4 ones are 4. 1 ones are 1. So minus 1. Here it will become reverse. 1 by 4 is 1. Minus 1 by 2 is 2. Now let us do the subtraction. 2 minus 1 is 1. 1 by 4 is equal to 1 minus 2. Greater number is 2, minus sign is there, so you will get minus 1 by 4. Both are not equal because I told you here in first rational number the numerator is positive and even the denominator is positive. Means P is positive number, Q is positive number. Here what happened? P is negative number, Q is positive number. These two can become equal if the numbers are same and sign are same. So we can say that for first example, the commutative property for subtraction did not prove true. But with for only one example we cannot say. Let us take the second example. So what we take? A is equal to 1 by 3 and B is equal to 5 by 7. So what we have to prove? A minus B should be equal to B minus A. So A minus B will be 1 by 3. A value is 1 by 3. Minus 5 by 7 is equal to 5 by 7 minus 1 by 3. Here you can see that both are prime numbers. So you have to multiply. 3 into 7 is equal to 21. So you got it as LCM as 21. So what happens? That LCM will become the denominator for left hand side also, and that LCM will become the denominator for the right hand side also. Take the first rational number. 1 by 3 into 21. 3 ones are, 3 sevens are. 1 into 7 is 7. Then what sign is there? Minus. 5 by 7 into 21. 7 ones are, 7 how much? 3s are. 5 into 3 is how much? 5 into 3 is 15. So you got it as 7 minus 15. Now let us go to the right hand side. What it is? It is just what it is. It is just the reciprocal. That is reverse. So what should come? First 5 by 7. What should come 5 by 7? 15. The next what should come? Minus 1 by 3 is what? 7. Now pay attention here. One positive, one negative. What I told, the denominator will remain the same. Take the bigger number 15, take the smaller number 7. 15 minus 7, it is how much? It is 8. Now what happens? 15 is negative number, the larger number is negative, so we will get it as minus. Here also same, 15 minus 7, 15 is positive, you got it as 8 by 21. So here also you can see both are not equal. Why? Because here the numerator and denominator is same, but what is changing? The signs are changing. So with these two examples we can say that commutative property for subtraction is not true for rational numbers. Next we will go to the next, what to call it as fundamental operation. What is the next fundamental operation? Is commutative property for multiplication. We will check it. What will happen over here? Just the sign changes. A into B should become equal to B into A. Let us take the example. What first example? We will take it. So let us take the first example. Then we have to also calculate the second example. So two examples we are taking for proving it, because one example is not enough, because it should be true for all the numbers. So first example, A is equal to 7 by 13, B is equal to minus 1 by 10. So what I have to do? A into B is equal to B into A. A into B is equal to B into A should belong to Q. What is A value? 7 by 13 into 1 by 10 is equal to 1 by 10 into 7 by 13. Last time only I told you when multiplication comes. Multiply numerator into numerator divided by denominator into denominator. Again, numerator into numerator divided by denominator into denominator. 7 ones are 7. 13 into 10 is 130 is equal to 7 ones are 7. 10 into 13 is 130. Both are integers, yes. Denominator is 0, no. Both are in its simple form, yes. So this belongs to Q. So first example we proved it is true, but let us try to prove with second example. A is equal to minus 5 by 7. B is equal to minus 3 by 10. So both I have taken minus sign. Let us see whether we are able to prove or not. So we have to prove A into B is equal to B into A belongs to Q. What is A value? Minus 5 by 7 into minus 3 by 10 is equal to minus 3 by 10 into minus 5 by 7. So numerator into numerator, minus 5 by 3 into minus 3 divided by denominator into denominator, 7 into 10 is equal to, again numerator into numerator, minus 3 into minus 5 divided by 10 into 7. So what shall you put? Minus into minus is what? Plus. So you will get plus 15. 7 into 10 is what? 70 is equal to. Minus into minus is what? Plus 15. 10 into 7 is what? 70. You can cancel this by what? Can you cancel it? Yes, you can cancel by 5. 5 3s are 15. 5 1s are 5. Then 5 4s are 20. 5 3s are 5 1s are 5 4s are. So you got it as 3 by 14 is equal to 3 by 14. Yes. Both are integers, yes. Denominator is not equal to 0, yes. Both are in its simple form, yes. So it belongs to Q. So what does it shows? That commutative property for multiplication is true for what? Rational number. Now we will come to the last fundamental operation. What is the last fundamental operation? The last fundamental operation is division. So let us see whether my commutative property for division is true or not. So what will the division means here? It will change. So what it will become? A by B should be equal to B by A. Let us see by taking examples. So let us rub the first example, because we are going to take two examples to prove whether it is true or not. So let us take first example now. What is the first example? Let us take A is equal to 3 by 7. B is equal to minus 11 by 6. So what I have to prove? A by B is equal to B by A. So first I have to write down A. What is A value? 3 by 7 whole divided by minus 11 by 6 should be equal to minus 11 by 6 whole divided by 3 by 7. So what you have to do? First I told you, like this fraction comes, first fraction you keep it as it is. So what is the first fraction? 3 by 7. Then what you have to do? The second fraction you have to take reciprocal into, what is the reciprocal? 6 by minus 11 is equal to. Next the same thing, minus, what will happen? 11 by 6 will remain as it is into 3 by 7 will become 7 by 3. Now what you have to do? Numerator into numerator. So 3 into 6 divided by 7 into minus 11. Denominator, denominator. This. Minus 11 into 7 divided by 6 into 3. So what shall you get? 3 6 are 18. Then 7 into minus 11, minus 77. Here minus 77 by 6 3s are 18. See here, the numerator is also not same, the denominator is also not same. So they both are not equal. So you can't prove it. Now let us take the second example. A is equal to 3 by 4, B is equal to 1 by 5. So what we have to prove? A by B is equal to B by A. So A by B is equal to B by A belongs to Q. So what is A by B over here? A is what? 3 by 4 whole divided by 1 by 5 is equal to 1 by 5 whole divided by 3 by 4. So what happens over here? 3 by 4 you keep it as it is. Division you make it as multiplication. So the denominator rational number become reciprocal. 5 by 7 is equal to. Here 1 by 5 will remain as it is. 3 by 4 will become reciprocal. 4 by 3. Now you multiply. Numerator into numerator divided by denominator into denominator. Again numerator into numerator divided by denominator into denominator. What shall you get? 3 into 5 is 15. 4 into 1 is 4. And here you will get 4 by 15. Both are not equal. That means the commutative property for division is not true for what? Rational number. So we saw two properties, closure property and commutative property, proving for rational numbers. So I will stop over here. Tomorrow I will teach you regarding the associative property and I will give you the introduction of irrational numbers. Goodbye. Thank you.